sort of first giga year, what might have happened. And in fact, we have something very exciting from the first several 100,000 years of the universe, which is really very early, which is the cosmic microwave background photons, of course. So basically, I mentioned about the giga years to give you some idea for the timelines, because we shouldn't expect the universe to change on the timeline of us human beings, right? In fact, another little reference for you here is that Earth and our solar system is around 4 giga years, right? It's around a little bit over 4 billion years old. And the sun is a relatively new star. It has, the sun and our planets were formed out of a nebula, a gas cloud, condensating at some point to make our solar system. And ever since, the sun, of course, has gone around the galactic center. So just like we orbit the sun, the Earth, I'll start with the moon. The moon orbits Earth, the Earth orbits the sun, and our sun orbits our galactic center. We have a supermassive black hole at the galactic center called Sagittarius A star. We have also mentioned quite a bit about this black hole and the galactic center. So the sun, you might wonder, in its lifetime of just a little bit more than a few giga years, how many times has it completed revolutions around our galactic center? And that number is only about 20 times. So the sun is not quite a teenager anymore in terms of our galaxy, because 19 would have been a teenager. It's 20, so it's a young adult in terms of stars. So quite young, quite new. And of course, there was no sun, as an example, when the universe was getting started. There were no stars when the universe was getting started. The first stars are what we call very metal poor. Yes, sun's old enough to party. Yes, the sun is not old enough to drink yet, in the US at least. Maybe the sun can drink in the Caribbean islands, US Virgin Islands, where you can drink at 18. It's a territory of the United States. So with different laws. So the sun is quite new, for example, in terms of the universe. The sun, another thing to note about the sun is that it's not considered a metal poor star, because it's a newer star and it was made out of that pretty metal rich. You can verify this and get more reference for this yourself. But when you are made out of a pretty metal rich gas cloud nebula thing, then chances are you're gonna have quite a few metals in you, like our sun does, and even we do on Earth, right? We have metals like gold on Earth, right? Where from do you think that comes? We all come from some nice metal rich enough thing that cooled down, condensated at various distances. Well, first of all, it made the sun, but also it made the planets sort of in the same plane as the sun, actually. Very, very interesting. Most of the mass of it went to the sun, and most of the angular momentum of this nebula that we come from, went to the planets. So, but we have these amazing things on our planets, including our own planet, and that is very nice. That is because we are relatively new, and enough time and enough sort of things happened where we got these metals, because really all of the elements above hydrogen, mostly, I would say definitely above helium, but even helium is made in stars. So when the universe was getting started, long story short, well, I don't know if this story can be that short, but when the universe got started, there were no stars, is what I was trying to say. So it was not very metal rich. There was indeed very few baryons, where baryons are, of course, ordinary matter, such as what we are made of, you and I.